All right, everybody. What's up, fifth period? I thought I was going to be able to leave this smelly room with a bunch of crumbs over on the carpet, but here I am making this video for you. I'm using my free software, so I got to do this in under 15 minutes, so you're welcome. So, all right. I go here. I go to downloads. I download the data sets. It's in my downloads. I go to RStudio. I import the data set. It's already a CSV file, so I hit browse, go to my downloads, there it is, rename it test, and import. All right, there we got all three variables. Final exam. One thing to note, the final exam is at a 200. It's doubled. That would be important to know going in, so always take a second and look at your data set. Make sure you aren't surprised by anything like that. We open up the test. It says create 3 scatter plots, best fit. Yeah, I'll just do one test so that you can see the whole thing. So first thing we're going to do is make a scatter plot, and we are going to make a scatter plot where we see if exam 1 is a good predictor of the final exam. So we run that, and you can see that's pretty good. Definitely a strong positive correlation. The higher you score in exam 1, the higher you're probably going to score on the final. Let's create a linear, let's give it a main title. Let's give it an x-axis label. Let's give it a y-axis label. Let me run that. There you see, boom, title, exam 1, final. Let's turn these little open circles to filled in circles with PCH 20. I personally think that looks a lot better. Let's change the color. This is where you saw where I had changed it to Sienna 2. Let's try Sienna 3, see if that looks any different. Sienna 2 is better. Plus, we don't want to have Sienna have a third bout of COVID. Okay. So there's the scatter plot, main title, blah, blah, blah. We need to now make our linear model. Linear model is the key to finding your R and R squared. It's the key to finding your residuals. So this is where you need to lock in. LM, linear model. What are we making a linear model of? Well, we're going to make a linear model that models this graph. So up here, we put the X variable first, comma the Y variable. Down here, we put the Y variable first, tilde symbol, the X variable. Okay, and what that just gave me was a y-intercept. Look, I just ran that. I didn't even name it yet. There's my y-intercept. There's my slope. Let me go ahead and name this line number 1. Save it over there. Booyah. And write my equation. So I'm going to use a pound symbol so that I can actually type y equals. My m is 1.852. My x plus b, which is 15.622. I'm going to store this for later, okay, because I might need it. That's my linear equation that models this first regression to see if exam 1 is a good predictor of the final exam, okay? All right, so now we need to actually get the line to show up. So let's say AB line of line 1. That's how you get it to show up. There it is. You can change the color for that same way. Let's make this color, what would look good? I just like gray better, to be honest. I don't know, I don't like the line of best fit to be so domineering. And then we need to find our R and R squareds and our p-values. And the way you do that is summary. What are you finding the summary of? Well, your linear model. So summary of line 1. And booyah, adjusted R squared. As predicted, that's really strong. 89% R squared. And then we got to find the square root of 89%. Let's ask Siri real quick. What is the square root of 0.89? Thought you'd say it out loud. It's 0.94. Okay, so we know that our R is 0.94 and our R squared was 0.89 or 89%. That means that this is a really strong positive correlation and that exam number 1 is responsible for 89% of the variability for your final exam. Like it can kind of predict, I guess, how do I want to say this? Exam 1 can pretty much predict 89% of the variability of how the final exam will score. So it's not fully responsible, a full 100%, but there's such a strong correlation that it's a great predictor of your final. Okay, but let's say, and you would do this for exam 2, you would do this for exam 3, and compare. Hey, let's talk about residuals for these last 5 minutes of the video. We need to, here's why residuals are important. And I want you to pull this off on your test. Okay? We need to figure out look at this person. They made an 82 on their exam 1. So they were projected to score about a 160 on the final, but they pulled a 185. What did they do? Did they get a tutor? Did they study really, really hard? Did they cheat? Did they, I don't know, what'd they do? So that'd be worth exploring. And then what about this person? They made a 78 on the exam. They were supposed to score like a 150, but they pulled a 140. Did they wake up? Did they not get much sleep last night? Did they not study at all? What about this person? They didn't do well on the first exam, and then they underperformed on the final. So they're struggling. Okay? So residuals are a key points to analyze. So the way we find them is with 3 lines of code. Okay? And we actually use this. That's why we wrote it down. Because the definition of a residual is the actual values minus the predicted values. So what we're about to do is we are going to find the predicted values for our final exam. Okay, if you scored a 60 on exam 1, you were projected to score a 120. So the predicted value would be 120. Like these are all just a bunch of points. That's all a line is a bunch of points. So we need to come up with just a table of all of those points on the line. And here's how we do it. We use this equation. So we are going to say that our predicted, let's do lowercase, our predicted final exam score is equal to our slope of 1.852 times, we use the asterisk in RStudio to represent times the exam 1 score. So test $exam 1 minus the y-intercept of 15.622. So let me pause there because I am going to store that. There it is up there. What did we just do? Well, this equation is specific to this graph. And what this tells us is that your x value, which is the exam 1 score, if you multiply the exam 1 score by 1.852 and you add 15 to it, you will get your predicted final exam score. So we just made, look, if I click on this, you don't have to do this, but like if I type that in and run that code, look, there's all of our 25 predicted final exam scores right there. You see this person's projected a 162, this person's projected a 71. Okay, so those are the predicted scores. So we have those saved here. So now, to find the residual final exam score, we are going to do the actual final exam score, okay, aka the actual values, minus the predicted final exam score. And what that's going to do is it's simple subtraction. It's what did you actually get minus what we predicted you to get, and it will tell you if you overperformed or if you underperformed. So when we run this, and it's saved up there now, residual final, we now have those numbers. Look, you can see the residuals right there. This person had a residual of 32, 28, 30, 38, etc. Okay? So then the last piece of code, and at this point you're ready to do anything I throw at you as far as linear regression goes, is we need to make a data frame so we can actually look at our answers. Okay, so I called it dsmith in last class. I'll call it dsmith for this one. My data.frame What do we want in there? We want, let's go ahead and put exam 1 in there. Let's go ahead and put the final in there. And then most importantly, let's put predicted final and residual final. So here's predicted final and residual final. And when we run that, I just created my own data frame of 25 observations of 4 variables that when I click, we see all the exam 1 scores, we see all the final exam scores, we see what we predicted them to get, and we see their residual. So notice, 152, the actual score, minus 119 is 32. Let's see who had the best residual. This person. They made an 81. That was our guy right here that we were talking about. This one, or our girl. Okay, the girl we were talking about scored an 81 on the exam 1, but pulled a 183 on the final, blowing away her predicted score by 48. Okay, who had the worst? Why are they? Interesting. Did I do something wrong? Final exam score 101, predicted final. Actual test minus, no, that's positive, yeah. What did this person score? This person made like a 54 or something, 53. That's them right here. So they made a 101. Oh, because it's out of 200, so it's doubled. So yeah. Okay, they underperformed predicted, but they still, or they scored, yeah. Oh, that's tough because the final's out of 200. Okay. You're hearing me kind of hash some things out right here. It's because they're on different, one's out of 200, one's out of 100, but that's all good because we can still see who did the best, who overperformed, and then the lowest number is who underperformed. Okay? Final exam score minus what your predicted final was. Okay? So that's really it. Take a look at this. Use this to make your cheat sheet. Can you make a plot? Can you find the line of best fit? Ooh, and if you stuck with the video this long, here's a freebie. Here's a freebie because this is going to show up on the test. What if I asked you, what would you make, what are you predicted to make on the final if you scored a 60? Because see this big gap in the data set? What if I asked you, if you scored a 60, what are you predicted to make on the final? How would you find that? What you would do is you would use a calculator. Look where my mouse is right here. You would use a calculator and you would plug in a 60 right there. Because if you do 60 times the slope plus the y-intercept, you will find your predicted exam score. So it works just like y equals mx plus b did back in the day in algebra. All right, I'm out of here. I hope this is helpful. Use the practice test. I don't know if the practice test asks you to find residuals, but I need to make sure it does. Make sure you practice finding those residuals, okay? Because you'll need it for the final, for the test. Good luck.